Welcome back to the Megatherium Club podcast. I am Sean, and I'm here with Zach and Spencer for the second part of our Triassic period episodes, part 2. Now that you have a good picture, well, hopefully, of what the Triassic period was like, we wanted to go around discussing some animals or plants, perhaps, I don't know, that we found interesting. And remember, this time period had some really different creatures and things going on. It was almost 252 million years ago to about 201 million years ago. Earth was recovering from the Great Dying and entering a whole new era, the Mesozoic, in fact. So, who wants to start it off? Spencer, do you want to start this one off?
Yeah, sure, why not? I also just realized we never actually said what we were doing, just in case we were all going to talk about the same thing.
Nope.
Well, I didn't really have anything planned, so...
So, yeah, well, I kind of picked things that would be at the end. I don't know, so I can't imagine we're going to have any overlap.
I'm going to riff here real hard.
Okay, do it. Love it. So, all right. The first one that I want to talk about is kind of a cool one. I'll talk about this one first. So, the Herrerasaurus, if I said that right. I believe you're supposed to technically say that with a bit of like an Argentine accent.
What does that sound like?
Because
I have no idea what that is.
Roll my R's, and I can roll my R's, but I'm not going to... Herrerasaurus.
You just sound evil when you say it like that.
Well, yeah, so
not to say Argentinians are evil, but like...
Or is it just...
Or any language that rolls R's.
Yes. So... Anyway, this creature, and I'm not trying to spoil anything here, but they lived in what is now Argentina. Go figure, right? Dating back to around 231 million years ago. So this is well within the late Triassic period. And so the first mostly incomplete skeleton was discovered in 1958 after a goat herder, of all people. His name was Herrera. So he was a goat herder, and there's two different stories. It was in the cliffside, or he actually stepped on them. Probably a bit of both. But he noticed these bones sticking out of the ground, and he decided to call them in. And so researchers came, they dug them up, and they're like, wow, this is like a brand new species. So they decided to name this species, or this genus technically, after this goat herder. I'm extremely jealous. But when they first started to try to categorize this animal, they're like, we don't really know what it is or where it fits taxonomically. And because there wasn't a whole lot of the skeleton found, it wouldn't be for another 30 years until they found a skull of one of these that they started to kind of piece together some more, pieces of the puzzle, I guess, for lack of something else. But they still can't quite, there's not an agreement on it anyway. So the pelvic structure of this thing is similar to that of the Saurischian dinosaurs. So these are the dinosaurs that would give rise to the two major groups of dinosaurs, the sauropods and the theropods. The sauropods being like the long-necked dinosaurs, the theropods being like the T-Rexes and the velociraptors, the bipedal kind of dinosaurs. And so they're like, okay, maybe this is like a missing link within that, kind of a transitional period. But this creature itself is also bipedal, and it looks kind of like a theropod dinosaur. So some scientists were like, nope, this is a true earliest theropod dinosaur. It's not a common ancestor between the two groups, but it's a true theropod. Yeah, but we're still talking about, this is a dinosaur. This is a really early dinosaur, but it's still a dinosaur. However, there's another group that's like, you know what? This is not a dinosaur at all. It should belong to a sister group of dinosaurs, or sister group of non-dinosaurs that are closer related but evolved not before them, but alongside of dinosaurs that would eventually go extinct. It's so frustrating, but it's so fun to think about. We just don't know. And it's because the fossil record isn't that strong for these things. I hope they find some more. But what we do know is, like I said, it's a bipedal creature, stood about as tall as the average human. So around 6 foot almost.
Wow.
But it also
that is a little tall
huge
for average human.
Okay,
I'm just teasing.
5'5", 5'6". I don't know. Yeah. That's how tall I am. So it's pretty tall, but it's also around 6 meters, or about almost 18 feet long. So earlier, in the last episode, if you might remember, I said that the earliest dinosaurs were kind of these small, inconspicuous little things. This was a beast of of something like that. But it still even wasn't a top predator in its region, which is crazy to say. There were plenty of larger reptiles that would have hunted these for food. We know that they were pretty fast predators, and they had one aspect about their jaw is that it can hinge a little bit differently than a lot of other, or at least they think, a lot of other theropods, meaning that, it probably might not belong to the theropods, and which is why other groups don't categorize it as a dinosaur, but it can open up its jaw super duper wide, and it has long, serrated, pointy teeth. So we know it was a predator. It would have hunted probably some smaller plant feeders like the small synaptids, the early mammal-like reptiles. And that's about it for all that we know about them. There's not a whole lot, but they're just kind of cool. And I don't know, the reason I chose this one is that it's up for debate because there's just not a lot of information known about it. I think if we keep discovering more, if we have better techniques, we might be able to categorize it more specifically. But I think this is one of the coolest things about the Triassic is the Triassic itself is kind of, I don't know, like it itself is the missing link between the weirdest creatures we have evolving during the Permian and then what everybody thinks about in the Jurassic. Mm-hmm. It's when everything was kind of evolving into what we are most familiar with. And this is just one of those creatures. So,
what was eating it? I actually am curious. I don't know if I know. What was bigger?
Oh God! The reason I didn't want to talk about it is because I was like, why didn't I want to talk about it? Right, the Rauisuchians are essentially they're archosaurs.
How do you spell
but they're larger versions of them. What's that?
How do you spell that? Oh,
Rauisuchians. Rauisuchians. They're closely related to crocodilians. They're large, four-legged.
Oh, like Postosuchus.
Sure. Saurosuchus is the one that I think most people.
Isn't that more of a crocodilian?
Yeah, but they're crocodile-like.
Pseudopsuchians.
Yeah, I think.
So they're not technically crocodilians.
Right.
They're right.
Are categories of archosaurs within a larger group called the Pseudopsuchians.
Spoiler, I will be going into detail. Maybe we can just go into that right now. I'll skip to that one.
Yeah, do it.
Okay. I didn't talk about the Rauisuchia, but I did talk about Pseudopsuchia, and maybe we can discuss what that means right now.
The pseudo what? Pseudotsuga?
Pseudotsuga
menziesii?
Whatever. Yeah.
Yes.
Mr. Douglas Fir.
I wanted to discuss the Redondosaurus, which belongs to a group of large semi-aquatic reptiles known as phytosaurs. If anybody knows anything about plants, that name might have caught your attention since phyto means plant. So these are
dinosaurs, plant lizards.
Well, plant lizards. There you go. Yeah, but they were yeah, they're plant lizards since the first fossils.
So did they photosynthesize?
Yes, you nailed it.
Hell yeah.
The first fossils were mistakenly thought to be herbivores. Now I want to describe this animal to you two and tell me the first thing that you think of. I might have given away some of the details with it being semi-aquatic, but I digress. Long reptilian-like body, quadrupedal.
Spinosaurus.
Stop. It's not Spinosaurus.
God damn it.
Long reptilian-like body, quadrupedal. So that Spinosaurus isn't quadrupedal. It's kind of maybe. We're not going to discuss that right now.
It depends on if you want to attack or run.
Legs out to the side of the body, sprawled, if you will. Long tail, large scales all over its body, small beady eyes on top of its head, long, narrow snout full of sharp teeth.
A crocodile.
Spinosaurus laying on its stomach.
God dang it. Well, actually, Zach, we're going to talk about that too. But Spencer, you hit it on the. Oh my God!
I get the gold star.
You get the gold star. Yes. So I assumed you would think of a crocodile. Turns out these are technically not true crocodilians, and there has been a lot of discussion on where this creature would fall on the evolutionary tree. Some thought they evolved before the Archosaurs split into bird-like, the bird-like line, aka the dinosaur line, and it's before it split into the bird-like and the crocodile line. And just to catch you all up on what an Archosaur is, they include all the reptiles that are living and extinct that are relatives to birds and crocodiles. And yes, birds are reptiles. We don't usually refer to them as such, but they evolved from them, as did the dinosaurs. Archosaurs are split into two groups: the Pseudotsuchians, crocodiles and their extinct relatives, and the Avametatarsalia, which include birds and non-avian dinosaurs and pterosaurs. Okay, we're caught up on the cladistic sense of these terms. Well, hopefully. Some people...
I don't think I've talked about the cladistics of the Heratosaurus at all.
Oh, well.
So, maybe I'll talk about it in my next creature.
Okay. I wanted to, because I think this is where it gets all, fascinating, is, people are all arguing where the hell these things are placed on the evolutionary tree, and then it's like, is it a sister taxon? Is it, is it under this? Is it basal? Is it extant? Whatever. But, anyways, some people thought phytosaurs, like Redondosaurus, evolved before Archosaurs split, while others view them as the most basal of the Pseudotsuchians. As you know now, they have a lot in common with crocodiles, so I understand why they claim that they came after the split and are relatives of crocodiles, but not basal forms of birds. There are a couple big differences between phytosaurs and crocs. One of the big ones is their ankle. I guess it was pretty weak. Actually, I don't know if it was weaker or stronger, merely suited for a different purpose, but it was definitely more primitive than today's crocs, or that's how it's described. I don't know what primitive means. Maybe it didn't have implants. I don't know. Crocs
primitive
today...
just means it's more basal, evolutionarily speaking, right?
Yeah, but what does that mean in an ankle? Is it less flexible? Is it...
Oh, I mean, it's just not as evolved, I guess.
I think we're just saying the same thing 5 different ways. It'd be like, this is a square has 4 sides, but yeah, all 4-sided things are rectangle. I don't know what it means to be more primitive in this situation, or what the ankle technically looks like versus today's Crocs, but I guess that's one way to identify it. Crocs today are capable of breathing. Jesus. Crocs today are capable of breathing even when their mouth is full of water due to a bony plate. It shuts off the water from going where it doesn't belong. Phytosaurs lacked this bony plate, but that's not to say they didn't have some sort of fleshy palate that acted the same way. Phytosaurs have larger scutes than today's Crocs. Maybe it needed more protection than its modern relatives today.
Could you tell me what a scute is?
A scute is those big scales that run down the back of an alligator or crocodile. Those just, I don't know, they look like big armored scales.
Oh, like a big armor plate.
Yeah. And I guess they were bigger back then, and it's what we can find in the fossil record. And, maybe it needed more protection. It also had gastralia, which I find interesting. Gastralia are belly ribs. You see these on proper T-Rex models these days. And I do say
proper ones.
Proper. Sometimes you'll see a skeleton that doesn't have it, and it really annoys me. But I think for the longest time, they weren't quite sure what to do with those bones. And so
they're not proper. That's what's wrong with them.
It's not very proper. But I think, eventually we've learned what they are. And they look like an extra set of floating ribs on the belly. It adds protection and support to the underside of the creature. Birds have these too, by the way, but not crocs. And the weirdest, probably biggest difference here is that phytosaurs had their nostrils on top of their head, up by their eyes, rather than at the tip of their snout like a crocodile. If you can picture a croc floating in a body of water, you usually see the tip of the snout and its eyes further back. So you have like two bumps sticking out of the water. Well, with the phytosaurs, you just have one bigger part sticking out of the water that would have its eyes and nostrils, so it can breathe and see, A side note here, and this is where the Spinosaurus comes into play. I believe, or the Spinosaurus, why did I say it like that? Spinosaurus and its relatives had their nostrils like this, where they were up by their eyes rather than the end of their snouts.
Does that mean phytosaurs?
Well, there's been a lot of comparison between them and phytosaurs, and I think a lot of people think of them as like this crocodilian dinosaur, but maybe we should be thinking of them as this phytosaurian dinosaur. And so they often do get compared to their lifestyle of like being semi-aquatic to phytosaurs, which is really cool. And I don't know, maybe they're more aquatic than I originally thought. I didn't really know much about phytosaurs. I'd always heard them compared to them, but I never looked into what a phytosaur was before doing this.
So do you think it's that Spinosaurs are phytosaurs, or is it a case of convergent evolution?
I think it's a convergent evolution because these guys were millions of years before Spinosaurus and down a different evolutionary tree, since these are pseudotsuchiids and dinosaurs are not. But a paper in 2023 by Chase Bronstein suggests that phytosaurs originated in the northern parts of Pangaea, spread south, and then eventually dispersed back north during the late Triassic. And back to Redondosaurus, since he was...
Did they make it to Gondwana? Or were they just in Laurasia?
I think they were spread out all throughout it. I don't know if that dispersal back to the north means that they were only found in the north by the end, or maybe just more diverse in the north. I'm not too sure on that. But Redondosaurus was first named in 1993. Shout out to the 93 babies. Hello, and fellow 31-year-olds.
What up, Redoncosaurus?
A.P. Hunt and S.G. Lucas were the ones that found it in New Mexico. There are two species, Redondosaurus gregori and R. bermani. These lived at the end of the Triassic and are the largest of the phytosaurs. Redondas were 20 to 30 feet long, so even though it was basal to modern crocs, this thing was massive. It was not a fast predator and relied on ambush techniques much like crocs today. It ate what it could and probably was an opportunistic carnivore. That being said, a lot of phytosaurs are compared to crocodilians such as the Indian gharial or other slender-snouted crocs. Do you guys know what gharials are?
Yeah.
Yeah, they look like aliens.
Yeah, they're really crazy. They have this super narrow snout. If you stepped on its snout, you probably break it. Like, they're kind of weak. And I actually know that because I used to watch the Pulsarino. Yeah, I went to India and just stepped right on it. I used to religiously watch the documentary around Sarcosuchus imperator with Alex, Serino? Is that his name? Paul Serino that discovered the super croc. And so the whole documentary is pretty cool, and they go into detail about the gharial and because it had a similar snout. But anyways, a lot of phytosaurs are compared to gharials due to their slender snout, and gharials are really delicate, and even though the creature itself is rather large, they really only focus on eating fish because that's all their jaws can handle. And so phytosaurs might get compared to that. Could they handle bigger prey? Well, Redondosaurus for sure can handle bigger prey than fish. And even though some creatures were bigger than them, they definitely fed on terrestrial creatures such as the dinosaurs at that time. And so that's Redondosaurus and the phytosaurs. I think it's pretty cool starting to discuss the pseudotsuchians and how some of those phylogenetic trees split.
Sick.
Zach, do you want to share yours?
Well, I didn't have much planned for this. So I'm just gonna riff on ginkgos.
Okay. Do it.
Yeah, so we talked about earlier, or in our last episode, because we're recording this totally at a separate time,
Yep.
that the Triassic period for about 10 million years was just like a period of recovery from the Permian extinction, where basically everything on Earth, up to 95% of sea life and 70% of terrestrial life went extinct. And afterwards, there was sort of this period of like evolutionary experimentation going on. And as we know with some experiments, some of them work. One of those being the ginkgo tree. So the ginkgo, it originated in, I think, like the middle Triassic, although I saw some non-peer-reviewed sources suggesting that it could have started in the Permian period, so maybe survived the Permian somehow, and then all through the Triassic, all through the Jurassic, Cretaceous, the whole Mesozoic until today, which is freaking nuts if you think about it, because this has got to be one of the oldest lineages of trees on the planet. And
Do you know that this is also a good example of a Lazarus taxon?
I did know that. Thanks for mentioning it.
Where can you learn more about Lazarus taxon?
Yeah, check out the Megatherium podcast. And we have a whole episode on Lazarus taxon where I talked about the Dawn redwood, and Spencer talked about coelacanths. And what did you talk about, Sean?
Well, I briefly mentioned ginkgo trees, and then I talked about a stick bug.
Oh yeah, that's right. That was a really cool one. It was like rediscovered. That's really cool.
Yeah, on an island.
Yeah, but well, speaking of islands, ginkgos currently are basically worldwide at this point. Like we had some at the University of Minnesota that like in the fall their seeds would fall onto the sidewalk and they would
my
god, it smelled like
so
shit.
Bad.
Oh my god.
It smelled so
They smell
bad.
so bad. But they're really pretty trees to look at, and other than the horrendous smell in the fall, there's really not like a whole lot of mess going on, and they're really durable trees, which I mean coming throughout the entire geologic time scale, like you'd have to be pretty tough. But before they were worldwide, at least the species that we have today, which is only one species, Ginkgo biloba or biloba, there's only like it's the last species of it. They were originally from Japan, and the word ginkgo is actually a misspelling of the Japanese pronunciation ginkyo, and it means silver apricot in Japanese. So that's kind of cool because the seeds look like like a silver apricot, if you could imagine.
That's exactly what they look like.
Yeah,
And they smell terrible.
They smell so bad, but I found something that I was looking at a little bit earlier about people that eat them.
But
Yeah. Well, I think they smell bad after they start to rot, but you'll see people who like
Checks out.
go around. I can't imagine they smell. I've crushed them, and looked at them when they're still quote unquote fresh. Yeah, no, people like go around and collect them.
Yeah, I'm looking at a
carry on,
picture
like,
of stir-fried ginkgo
pillowcases.
seeds, and it doesn't look half bad, honestly. Like, I would try it.
I would too. Not yeah.
But yeah, apparently. So I guess moving on from that, ginkgos are unique, as we talked about in the last episode, because they are gymnosperms. I was gonna say that they are the only deciduous gymnosperm, which is false because there are larch trees and other deciduous coniferous trees that are also gymnosperms. But to my knowledge, it's the only broadleaf gymnosperm that exists, which is really cool. They have really distinct leaves that are sort of like wide and fan shape, And one cool thing about them is that they are what is known as dioecious, which means each tree has a different sex, basically. So there are male trees and there are female trees. And maybe this doesn't seem like that crazy to you, but I always, like, when you think of flowering plants, they're usually what's called, or I always think of plants that are what's called monoecious, where one plant has both the male and the female reproductive parts. That is just not so with the ginkgo. There are separate trees for the pollen cones and the ovules. That's just another thing I think is really cool about ginkgos.
They're very cool. I didn't know about them until I moved to the Midwest, and people plant them. Some people hate them.
Is it because they
think
smell?
Because of the smell in the fall.
Yeah.
Yeah, I think that's mostly what it is. But I remember the first time seeing one of their leaves, and I was like, "What the hell? This thing looks like a dinosaur tree." If I can say that, right?
It's not a dinosaur. It's older than the dinosaurs.
I know,
significantly older, millions of years. That's what I'm getting,
like millions of years. Yeah. So, yeah, I think that's a very good choice.
We say that, and I do have ginkgo leaves tattooed on me next to a dinosaur.
Ooh.
Good thing they don't have like the scratch and sniff tattoos.
Gross.
I'd put it by my.
I mean,
butt.
I'm still gonna scratch it, and I'm still gonna sniff it.
I'm gonna give it a taste too.
Oh, perfect. Yep. Yeah.
Stir
All right,
fry.
get ready, Sean.
I'm ready.
Oh, gross.
But yeah. Anyways, while ginkgos, like the ones that we know of today, are mostly from China, Japan, they used to actually be very diverse and distributed worldwide, because we have ginkgo fossils from both the southern and the northern hemispheres. So they used to be everywhere, which is something that I think is just crazy. It's another Dawn redwood kind of thing, where it used to be everywhere, and now it's just, at least natively, it's only in like a few areas. Like the Dawn redwood only has a couple stands of it left, but and ginkgos, well, both of them are kind of worldwide now, but that's only because of human intervention, which is, yeah, good for them, I guess. Way to go, ginkgos.
Yeah.
Well, I can transition from there into another quick one here.
Go for it.
I had to shout out a couple of different things relating to this species that I'm going to talk about. So, the Coelophysis, which is so hard for me to say because it's spelled C-O-E, which is co to me because I went to college.
Nerd.
So if I accidentally say Coelophysis, I apologize. That's not how you say it at all. Coelophysis. This is a genus of dinosaur. It is a true dinosaur. It is a true theropod dinosaur, meaning, it's related to things like the T-Rex. But the genus, it only has one species confirmed to the genus. Originally, it had a bunch, but like a lot of dinosaurs, you fast forward like 60 years and they put them all together. It only has one species within it. But it was discovered originally by, do you guys know who?
No.
Well, you should know a fellow Megatherium Club member, Edward Drinker Cope.
Oh, dang it.
So of the Bone Wars, if you want to learn a little bit more about that, you can listen to our very first episode about some members of the Megatherium Club. So anyway, so it was discovered in the 1880s, 1887 specifically, by Edward Cope. Yeah, was kind of determined to be one of the oldest dinosaurs. So they lived around 215 million to 208 million years ago, smack dab right in the late Triassic period. They lived in what is now the southwestern United States, so think Arizona, New Mexico, But back then, yes, it was still kind of dry, or at least they had dry seasons, but it was very different than what you see today. And if you want more information about that, listen to the previous episode. Maybe not about that region, but just about what it all looked like. So, but very different. And this area was specifically marked by seasons of monsoon rains and seasons of very dry. So dry that, think of like the savannas of Africa, where a lot of the water resources will dry up, and then animals have to congregate in specific areas that still have some water and have to interact with each other. And that's kind of important for why these are some of the most important dinosaurs ever discovered. So originally only a few were found, and it wouldn't be until the mid 19th century when all of a sudden in New Mexico at Ghost Ranch, they discovered a plethora of fossils of all of these same species. So many of them, and you can still find them there. And so we were able to bounce our research about them forward tremendously. So we learned a lot about, they're dinosaurs, but like a lot of the true dinosaurs, specifically the theropods, these, like modern birds, had hollow bones, meaning that they were very fast. And they stood about 3 feet tall or so, 3 to 4 feet tall, depending on, some resources, and were about 9 feet long. So they're very long, they're bipedal, and you can imagine that a lot of that length comes from the tail. Well, being small, being bipedal, they were runners. They were fast predators, and they have some of the earliest evidence of fusion, the specific type of fusion within the tail vertebrae that essentially makes it so the tail vertebrae can't move up and down, but only side to side. And so that essentially acts as a counterbalance for when they're running. Depending on what leg they're on, the tail will swing in the opposite direction to make sure that they can stay upright, and makes them even faster. And also having hollow bones means you're lighter, and that means you can be a little bit faster. There's some evidence to the contrary. Some people think that they might have been able to to hunt in packs, but when scientists started looking at their arm bones, if you're going to hunt something in a pack, that usually means you're hunting something bigger, and that usually means you have to grab onto it, this kind of grasping ability. Well, their arms are pretty weak and underdeveloped, like a lot of theropods that would come kind of after them.
What about their face?
So they're like, their face?
Yeah.
Like
they bite.
like their jaws?
Yeah, they bite hard.
Yeah. I mean, they had pretty strong jaws, and they had serrating teeth that pointed backwards that are really good at holding on to something. But if you really want to do this grasping thing, you have to be able to hold on to it. Yeah, you can hold on to it with your mouth, but you might need a little bit more than just your mouth. I mean, even some of the larger cats that use their jaws to hold on to something, they're going to be also holding on with their arms, right? And so the idea is, okay, they probably didn't hunt in packs, at least for larger prey. They might have been able to hunt for, things that are about their size and smaller, and that's probably what they did. The reason that they found this huge plethora of fossils was they predicted that during the dry season, a large group of them got together at like a watering hole, and then there was a flash flood, and it essentially just brought all this mud, wiped them out, and covered them up and preserved them and fossilized them. And so it's kind of hard to, from that, really determine their social behavior. But eventually, from some of these types of behaviors, these gathering behaviors, came about some dinosaurs that truly did hunt in packs. But again, these are the earliest of the dinosaurs. So, these are potentially setting up those types of behaviors. I didn't have a good way to end this because I kind of was ending it thinking we were going to record these 2 episodes together for some reason. I know we talked about it, but I had a transition that no longer works. So I'm like, oh, how the fuck do I?
How?
And how? No, just kidding.
Well,
So,
I have a way to transition if you want me to.
yes, please.
Go
Oh my
into it.
God.
Okay, cool.
Save
So
this podcast.
I see that the Coelophysis is an early dinosaur, but we've alluded to something a few times in this episode, maybe even the last episode, about what is a true dinosaur and what isn't. And so I wanted to talk about something that's, on that topic, and it's called Silesaurus opalensis. And at first glance, it would appear to be a dog-sized dinosaur that is slender with a long, thin tail, slight build, not a long neck, but reptilian dinosaur-like, quadrupedal with longer, beefier hind limbs than front, and a slender, narrow face that also appears dinosaur-like. Any person that might not know better would assume this animal I just described is in fact a dinosaur. But it isn't. Silesaurus, yeah, ooh, shocker. Silesaurus is a genus under the family Silesauridae, which is a sister clade to the dinosaurs, the Dinosauria family. But what does that mean? Silesauridae and dinosaurs shared a common ancestor that eventually split into these two families. So Silesaurus is not a true dinosaur, even though it has some remarkable similarities. It was around 2 meters in length, and its head would have reached around the height of your waist or maybe mid-chest. Some Silesauridae fossils date back to 240 million years ago, so right in the middle of the Triassic. This genus has been moved around on the evolutionary tree, having once thought to be basal ornithischians. Those are dinosaurs. That? Yep, you beat me to it. Those are dinosaurs such as Triceratops, Stegosaurus, Ankylosaurus, etc. Silesaurus.
Does that have a meaning? What is a saurischian by definition?
Ornithischians? Is it?
Yeah, ornithischian. Is that what you said?
Yeah, ornithisch.
Is it bird-hipped?
It's something like bird-hipped, but I want to make sure.
Well, remember that bird-hipped came about twice.
It's
There's the
characterized
bird-hipped.
What?
Oh, sorry.
No. So it's characterized by a pelvic structure superficially similar to that of birds.
Ah, yes.
Nailed it.
Yeah.
Nailed it.
But
not
theropods.
The pelvis that would become birds.
Yeah, it's really funny.
Really
because
stupid.
Birds are only distantly related to that group.
It is a superficial similarity.
Yeah.
Yep.
So, where was I? What did I do wrong? So it was thought that silesaurids were basal to ornithischians, but that is not the case. Silesaurus also had a keratinous beak at the end of its jaw, similar to those dinosaurs that I just mentioned, so I understand why scientists might have thought this was true. For a while, scientists also thought they were bipedal, like early dinosaurs were, but more research would show that they were actually quadrupedal, and being quadrupedal kind of throws off the possibility that these were early ornithischians, since early dinosaurs were bipedal and then would have had to lose the bipedalism to become a Silesaurus-like dinosaur and then evolve it again in the case of some dinosaurs like hadrosaurs and then lose it again. So it just didn't sit well. All these instances of gaining bipedalism, losing it, gaining it. And there's also other explanations, but I did think that was kind of funny. Silesaurus appears in the fossil record through a number of ways, including fossilized bones, footprints, coprolites, which, by the way, for a refresher, is poop. It was originally believed that these animals were herbivorous, but scientists noticed irregularity with the teeth and switched the hypothesis to omnivorous. Then, with the coprolite findings, poop, they noticed that these dino-like creatures, dino-like creatures were also eating insects. Cool fact that they found one insect so intact, and I think it was a beetle, so well preserved in its coprolite that they were able to give it its own family. And I think the species was like coprolitis or something. It's kind of cool.
Nice.
Poop bug. These creatures had a high metabolism like today's birds and would have foraged for insects much like birds today. Think of chickens walking around with a quick sudden movement picking up bugs. Though scientists still believe that they also ate plants, so they still call them omnivores. More derived silosaurids were thought to be more herbivorous, while more basal members of the family were carnivores. A big difference between silosaurids and dinosaurs is how the hips meet the femur. And this is where we get into the weeds. Dinosaurs and mammals, actually too, have what is known as an erect form, where the femurs are beneath the body, not sprawled out like if you can imagine a croc, and the hip bones do not extend out over the femurs. And in dinosaurs and mammals, the ball joint is at like a near 90-degree angle into the hips. The legs come up and then out comes the 90-degree angle ball joint into the hips, into the leg. In silosaurids, as well as other early dinosauromorphs, you see this pillar erect limb posture where the legs are beneath the body, but the hip bones extend outwards and the legs attach below, not at an angle with the ball joints. They're just directly below the hip bones. What is the benefit of this? The pillar erect might, have more weight bearing capabilities, while the basic erect allows for more movement, more speed. That's just a theory. Evolution was playing around with different methods of locomotion, and it would seem like
you can do it.
I don't know if I made any sense in the sentence that I typed out. But evolution was playing around with different modes of locomotion, and some of these would go on for another hundreds of millions of years, and some of them would die out. But thought Silosaurus was a cool example of not a dinosaur that looked like a dinosaur, and it's also why I chose the Phytosaur, because it looks like a crocodile, but it's not a crocodile. And that really kind of sums up what was going on in the Triassic.
Yeah. Triassic,
a lot of transitions. Boy. Yep. Yeah, I would agree with you from our last episode. I definitely think it's underrated.
There's some crazy things going on, but it's fascinating. I think one big group that we barely touched on and could always come back to in the future are those Rauisuchians, the land pseudosuchians, the land gators that were just like the apex predators
everywhere. Yeah, just giant armored reptiles that couldn't hack it when the climate changed.
So like the Triassic is like, which is weird that we didn't actually go into that much detail, but isn't it like ruled by like the crocodilomorphs and like the pseudosuchians? It's not the time of the dinosaurs. They're just getting started. It's like the time of the ancestors of the crocodiles.
Yeah. It's the time of the giant armored reptiles. That's what it was. We could do a whole episode just on those sometime too.
Yeah. It's cool.
Sweet. Well,
hope you guys enjoyed the episode. That was a fun couple episodes about the Triassic.
Yeah. I think if you have ideas, if you have a specific time period you guys want us to cover next, please let us know. You can reach us at what?
1-800-SAFE-AUTO. No.
1-800-588-2300.
The megatheriumclubpodcast at gmail.com.
Okay. There we go. That's the one.
All right, we got it. It doesn't have quite the nice little ring to it like the others. No. But
Spencer, do we have an update about our social media?
Oh, yes. We do have an update. I haven't asked if I can give her name, so I won't be giving a name. But we have somebody who's going to help us where we struggle the most, I think, and that's social media presence. Sean and I are really going to attempt to up our social media presence on Instagram and TikTok. And to help us with that, we've hired an intern.
Woo!
I think hired might be an exaggeration.
Hired is an exaggeration. Intern is an exaggeration.
A volunteer.
We have somebody. We have a fan, a friend of mine who is just a wonderful human being that wants to essentially help us kind of pull sound bites and other things like that, and kind of help our presence on a lot of different stuff. She's not going to be running our social medias, but she is going to help create maybe some content for that, so that she herself can create a little portfolio that she might be able to use to get into grad school, blah blah blah, whatever. So we're really excited for her to join the team. I think maybe some episode after we kind of get things going, she can just pop on and say hi if she wants to. Again, I haven't talked to her about this at all. These are just some of my thoughts. So if she listens to this, okay, here we go.
You're hired.
But we're going to have a conversation pretty soon to kind of finalize some more details. But we're really excited about this new kind of chapter moving forward for at least a little bit. And yeah, I thought there was something else I wanted to talk about, but must not be important. That was the important one. So please stay tuned.
And we do have a cool wrap-up planned. Hopefully we'll get to it, and maybe things will change before then. But we've discussed revisiting episodes, seeing what has changed in the last 12 months in science, that maybe we need to revisit and update you since the science is updated.
I think we're definitely going to try to do that. So, well, as always, how?
How?